Section 2. Equipment description. Car 1. Car types. The following general information pertaining to the various types of railway cars and navalway installations are see figure 2.1. Box car, flat car, hopper car, gondola car, tanker car, intermodular container car, and also underframe car, what we call fish belly. Box cars are utilized for transportation of various commodities that needed protection elements. Form the compatibility transfer methods. Box cars provide a good shield and secure blocking storage. They are available in storage standard interior lengths of 40, 50, and 60, and up to 86.5 special service designs, and tonnage capacities of 400 to 100 tons and 40 to 100 tons. Cars vary in lengths and types of doors, plugging and sliding, both wall and floor construction, loading, securing systems, and degree and method of underframing and cushion. Tanker cars are utilized for transportation of a wide variety of liquid commodities and military commodity. Military Handbook 265 gives you the tonnage capacity for the tanker cars. For the Navy chief commodities of various petroleum fuels and shipping waste and capacities range from 10,000 gallons to over 34,000 gallons. And cars vary in construction and riveted, welded installation material, steel, aluminum, wall valve type, locating, heating method, and undercarriage design of center and stub sills. Flat cars are used in loading items whose dimensions cannot be otherwise accommodated. Protection of elements is necessary way of loads are securely extremely important for loads on the flat car. Flat cars are built variety lengths from 40 to 89 feet, capacities are up to 125 tons, and more than limited to special service cars that are more than 4 axles on the car. Hopper cars are both covered and uncovered variations. Bulk items, coal, iron, appropriate open top hoppers or covered hoppers are used. Commodities, grain, plastic, pellets, and environmental condemnation of protection are necessary. These cars are variety in length of up to 55 feet and 125 tons of capacity. Gondola cars. The gondola cars are essentially flat cars with sides. They are used with such commodities and pipe, scrap metal, fabricated steel items, and the gondolas are usually used for commodities. Environmental contamination protection from the elements are not necessary. The method of loading and unloading is a factor in the use. And in their use, intermodular container cars are long, flat cars designed so especially to carry either a piggyback trailer containing, sometimes called the TOFC or the COFC cars. Intermodularly are equipped with a container pedestal, sometimes a piggyback trailer here hitches. Two rail car components. A freight car compromise basic elements are shown in figure 2.3, 2.3, 2.4a, 2.4b, and 2.6. Center sill and stub sills. The center sill is the backbone of the car, is the main structural element carrying the load of the individual. The center sill is always also to transfer the various longitude forces encountered during the train operations from car to car. Some tankers who utilize a tank and transfer carry various loads usually handed for the center sill. The still have what have called the stub sills instead of center sills. The end sills, body sills, end sills, and side sills, along with the end sills of the frame, provided with structural integrity to the car in reference to the center sill cross bearing and cross tie. The cross bearers and the cross ties are run perpendicular, and center sill transfer load is the deck to the center sill body bolster, body side bearings, the body bolster, which also runs perpendicular with the center sill, providing the connection between the railway car center sill and its trucks, and load and transferred bodies bolster truck to the center plate within the side bearings, providing stability. And the coupler truck transfers between the car and the freight cars. The locomotive coupled in the coupler and comprised with the shank and the head of the knuckle, and the shank is secured in the draft system. The knuckle is used in a couple of the other knuckle of the other freight cars. Although the several types of all couplers and interchanges in the United States on the Navy car and rails interlocks. And see figure 2.4, 2.4b an illustration of the coupler components of see figure 2.5. The illustration different of coupler type. The body bolster, the center sills, cover plate, the flag string, floor stringers, and the body bolster. The end sill, the gear pocket, the diagonal braces, the side bearing, the body bolster, the side sills, the cross ties, the cross bearers, the center sill, the stake pocket, and the body bolster. Rail car components: the brake shoe, the brake hanger, the brake lever, the center plate, the axle, the side bearings, the bolster, coil springs, spring plank, the side frame, the journal boxes, the connecting rod, the rail, the wheel, the brake shoe, the brake hanger, the brake level, the center plate, and the axles. Draft gear and draft gear pocket. Each comes with their some form of draft gear from the cushion of the coupler, absorbing the transfer forces of one car to the next. Drafter gears incorporate the various types of cushioning devices. Example for the drafter gear system: trucks, car have been a pair of trucks transfer the weight of the control car, provided the method of the guidance. Although the truck may have the 4 axles, frictions, and roller bearings, car mounted on truck mounted brakes, that they all have some basic components of wheels, axles, journal, side frames, bolster, center plate, side bearings, various brakes components, including rods, beams, hangers, and shoes. And see Figure 2.3, the description of the truck parts. H is the center seal cover plate, a flap riveted welded across the steel center plate, either above the below, given additional strength. Floor strings are sometimes applied with a flowing nail strip member acts as support of a nail strip. A diagonal practice, diagonal brakes, a horizontal extending diagonal from the end of the sill back to the body of the bolster. Stake pocket, metal receptacle collar attached to the side end of the side sills, and the end stake which support the side confines the load. Car breaker system. Railway car have 2 braking systems: handbrake and air brake systems. Air brakes are primarily means of railway cars that are slow to stop. Figure 2.4a is a coupler of the A type coupler with a knuckle and a knuckle pin and a shank. Type B is an AE and F are coupler heads. Knuckle side front. S south and B coupler front guard arm side, the top and bottom coupler head, and the bottom. Type F interlocking and tie interlocking type hot coupler. The coupler hand is lubricated for front face knuckle side guard arm, horn lock chamber, top lock lift guard arm, hose guard arm, and face lock hole, thrower hole, disarm hole, rotary shaft wall. Provide pivot lug, pivot pinhole, pin protector, buffering shoulder, pulling lug, hold knuckle tail wall, lock wall, lock guide and knuckle side, knuckle guide guard side, arm side, throwers, retaining lug, top operation, anti-creep ledge, rotary operator, anti-creep ledge, knuckle stop, lock of the wall, support shelf, vertical gathering surface, interlocking wing pocket, lateral allowing and chain log, auxiliary interlocking lug, and rotary shaft hole in the rotary shaft keyway inverted in the pin support, interlocking lug, and intention surface knuckle side support wall, chamfer, cottering key opening back support wall, guarding and sole guarding inside support wall, shelf front face. And those are the Figure 2B4 coupler components: standard E, standard SE, standard SEBE. The F-type E, those were the E-type styles. The standard F-type standards are standard F and standard SF coupler types. The example of a draft gear: a key slot coupler and key draft gear and support plate, vertical yoke and bolster center line. The M handbrake system: the handbrake is mechanical linkage operated. The railway manual applied to the brake shoes of the railway car, whereas in locomotives all cars are equipped with handbrakes operated on normal surfaces. Handbrakes are used to securely after spotting and stopping an emergency for the special switching moves. The handbrakes usually located on only one end of the car, and this end is the B end. The cars with the handbrake at each end of it will have been stenciled to the B end. The handbrake should be applied when required using the proper procedures at the point potential of accident, serious injuries. Air brake assembled in the freight car trucks. Air brakes, the system of the air brakes, airline brake valve, brake cylinder, S is assorted linkages, rod chains, and handbrake connection. As previously noted, it is brake cylinder and mounted on either car body of the trucks. See the figure 2.7, the typical air brake system layout. The typical component air brake system. See figure 2728 in the schematic railway car brake system and mechanical components. The brake pipes are carry compressed air, brake valves that control the brake application, brake cylinders that are braking force, brake rigging transferring the brake force to the brake shoes that are applied to the force of the railway car. Other ways components are sometimes required actual valve, cylinder, and shoes into that type of variants. Some of the long special services require various additional values of properly functioning air brake systems. An example, a modulator required for some car using component composition shoes. Due to the function of air brake systems, the air brake system operates as the storage reservoirs was located on each of the car and charged and compressed that the reserve separated the brake pipe delivers compressed air and by the brake of the valve. The brake valve shins the pressure drops in the air brake pipe utilize compressed of the air reserve air apply the brake plies, and since the pressure initiates in the brake pipe application is designed in the brake built into the brake end safety features a significant quality of quick loss of air loss such as could occur in braking 2 and will result in automatic emergency full force application of the brakes using air located in the separate emergency reserve. The air brakes are controlled in control stand and locomotive. The operator automatically brake release the air brake of the brake pipe. The loss in air pressure and since the individual brake valve is on each rail car in the consistent each rail car valve and then applies air brake in direct proportion of the brake pipe reduction causing the operator from the air reserve located in the railway car brake position applying the brakes on the railway car to the brakes operating the standard procedure of the brake pipe placing automatic brake valve and release the brake position of the brake valves each rail car consistent sense the increasing pressure of the exhausting brake position thus releases the brake pipe pressure is recharging air reservoir on the railway car after a period of equilibrium will reach the brake pipe and will be each feed cocked pressure although the pressure will be having released in all rail car air reserves will be fully recharged. Type brake system. The railway cars enable activities variety of air brake systems ranging from the K-type brake on the older cars to the ABW types of braking on the newest cars in the AB and ABD system being the most common. The K brake is the K series of the K brake. KC, the brake cylinder combined with the air reserve. The KD is a brake cylinder detached from the air reserve came in the early 1900s, and only the oldest Navy cars have the type of the system that have been being phased in the figure 2.9 picture of the KC, the brake and valve in the air reserve. The AB brake that provided the following advance over the K-type slate brake pipe pressure and functions reductions the intended brake applications. Quick surface propagation is twice as fast as release and recharges air faster than brake cylinders pressures than more often than are less sensitive than brake pipe leakage on brake systems on the brake valve of the brake cylinder air reserve and the mount separated. See figure 2.2 an illustration of air brake the AB brake valve. The ABD 1961 the maintenance advancement of the AB valve the use of diagrams and the O-rings in place of pistons to reduce wear weight of the repair complexity. See figure 2.10 the illustration of ABDW in 1976 current brake system installed on all new cars and maintain advancement of the ABD faster and brake applications in continuously quick and action of the accelerated service application valve. See 210 the figure for the ABW valve. Now here's what you got, and you got your picture in the rail car brake system of the air figure 2.7. You have your AB1 brake cylinder going to the modulator valve headed to the ABD valve, which is sent to 2 3/4 emergency rail pipe and 3 3/4 auxiliary reserve and 3/8 of a retaining pipe. The retaining valve goes to a F3 retaining valve, while the 2 emergency reservoir pipes and auxiliary reserve pipe go to the combined auxiliary reserve pipe, and as you pass and it goes also from the ABD valve, you go down to the combined dirt collector and branch pipe cutout cock mold number 2, and one branch pipe number 2, and then that 1 1/4 inch and 1 1/4 by 1 inch branch pipe T, and then to the view of the, and then the brake and the 1 1/4 brake pipe goes into note number 3, and then it goes a quarter inch pipe straight coupling and a 1/4 inch pipe nipple, 10 inch long AAR standard air brake hose with a 1 1/4 inch ball cock on both sides. Note that all brake piping extreme heavily except nipples at the angle cocks, which may be extra heavy to standard weight. The length of the brake pipe, including the combined collector as the cutout cock, should be 22 to 40 inches. Flexible branch pipe, hose, cushions, and type underframes be installed in accordance with the AAR. Reduction of the valve installed with the accordance with the AAR standards. 2.8 The railway cars system's mechanical components. You can follow it from a handbrake rod, from a wheel change push rod, into a lever guide with a cylinder lever with a cylinder rod, to a chop of a truck lever, live bottom rod, truck dead lever and dead lever fulcrum, and the brake beam fulcrum. The floating lever fulcrum, lever guide, floating lever guide, top truck rod, track lever guide, the bottom rod, brake beam fulcrum, truck dead lever, dead lever fulcrum, railroad brake system mechanical components. KC is a brake valve in reserve. The ABD and ABW type service brakes on 210, 3-point Navy locomotive types. See the Dragon. The list is pertinent flags of a S1 1200 120 ton, a GE 80 ton, a GE 44 ton, a Baldwin 120, and a GE 65. The EMN, these go over the locomotive's horsepower, the poundage, and the consistent tractive efforts at 30% and 10 miles per hour, and minimum curved radiuses in their weights. The locomotive propulsion and brake systems. The locomotive power generation of the Navy equipment fleet of the movement railway cars consists of a diesel-electric locomotive along with fewer car movers in location. Diesel-electric locomotives are used in diesel-electric locomotive coupled and generator alternator to reproduce direct power of the direct DC traction motors located under the locomotive axles. The locomotives are both 1 and 2 diesel engine designs. Sometimes can be operated independently. Other than those, can be operated on multiple unit services. And multiple unit services, coupled units, always controlled only one unit of the units. Sometimes the unit is the road switch compatibility changes, operating change characteristics of unit depending on use of the locomotive or rehabilitated current policy and standardization. All locomotives in 26L series brake system are better than AAR control standings. See figures 2.4, 2.15 pictures of typical 2611 or L series brake and AAR stick control stand. The locomotive traction system is a diesel-electric locomotive and controlled by the government. Maintains a constant engine and loaded regulator. Maintain constant power and output for each power setting selected by the operator. Actual track effort and transferred for the rail may be limited to the less than power setting and reduced adhesion due to such factors as contaminated rail grease, water, etc. Lack of sand applied to the rail. Wheel slip and will occur in the case of certain locomotives that power output automatically reduced in predefined periods of the time until the wheel is slipped. Wheel is corrected. The locomotive brake and system. Each locomotive is an independent auto brake, air brake valve, mechanically operated hand brake. The independent brake control of the brake cylinders on the locomotive is primarily way reducing the locomotive speed. Locomotive is operated with no car's automatic brake valve. Controls of the car locomotive brake shoes and primary means of reducing train speed, and the locomotive brakes are bailed off and released in the operator until shortly before they completely store. The handbrake and secured locomotive locomotive and left unintended attempts to stop the locomotive emergency from its air brakes fails to function. The locomotive is equipped with various systems of the 6RL, 24RL, and the 26L series, and etc. See the figure 2.16 in the schematic in typical series of 216 locomotive A air brake system. Now, figure 2.11 shows a generator, an engine, and traction motors and a compressor. And 2.12, the center cab locomotive, the locomotive throttle, reverse handle, line contact, two line contactors, the locomotive pneumatic pressure, and number of power plants 1 and 2, and number 1 and 2 trucks, which is also known as kind of like a bulldozer. Now, locating the apparatus, 65-ton diesel-electric locomotive is the locomotive apparatus and a 65-ton diesel-electric locomotive. The platform 1, 2, the engine plate, the end steps is 2 and 3, the diesel engine, 4, the fan, 5, the traction generator, 6, the alternator, battery, change, charger, 7, the engine cooling radiator, 8, the exhaust muffler, 9, the air compressor, 10, the air compressor equipment, RS, 11, the high voltage control, LFs, 12, the low voltage control, 12, the air control stand, 13, the cab heater, 14, the battery, LS, 15, the headlight, 17, the tractor, 18, the traction motor, 19, the AP general boxes, 20, the brake hangers, 21, the gearbox, 22, the bell, and 23, the horn. 26, the L brake control panel, equipment is 26L brake control equipment, the automatic air brake handle, the independent brake handle, the multi-unit brake valve, cutoff valve, and train air compressor knobs. While in the AAR-105 control stand, you have the bell ringing valve, the independent brake valve handle, the automatic brake valve handle, the standing switches air horn valve handle, air selector switches, air brake gauges, loaded current indicator, PCS, open light, wheel slip light, signal light, the standing light, the engine running switch, the generator field switches, the control fuel and pump switches, the throttle, the miscellaneous light switch, and the reverse handling, headlight dimming switch, and the heater fan switch, and the safe controller foot bar. Now, in the 26L brake system, you have the brake, you have a gauge pressure gauge hose, a ball and angle cocks, the train line hoses, the ball type cutout cock, the H and O PW obtaining gauge shoulders. Anyways, I can't read that, it's too small. But miscellaneous equipment, the cranes, the movement of the cranes, and the override the railroad track conduction of the extreme caution cranes, usually short distance between the trucks and track. Loading is more than a concentrated most rail cars. The care shall be taken on the track lesser than class, be adequate for other loads. The bottom range crane may be exceed normal railcar plate clearance and enveloping dimension and crane and be handled and wide loaded with potential clearance problems. Consider the movement and within the crane should be potential clearance and problems. Consideration movement and possible cranes should be moved into the boom. Trailing is minimizing accidental release risk or boom switches outward. Cranes shall not be moved in excess of their rated speed. If the crane is not being moved or under its own power driven train shall be resolved to prior to movement. All railroad cranes should be properly weighed, tested, and certified in accordance to the Navy Flag PR37 before putting it into service. The car movers vehicles can be operated in the railroad when the rail supported both steam and flange wheels and rubber ties. If rubber ties are used in attractive effort braking, all car movers or couplers coupling into the rail cars. Some are also capable of operating air brakes in the coupled rail cars. See figure 2.17, an example of car movers. The car movers operated in locomotives shall not be placed on any track until permission is granted from dispatcher. The number of cars moved on one time should not be exceeding the rated and the capacity of the car mover, and no shall be exceeded which can be safely stopped, and care should be taken in signalizing crossing. The car mover might not activate the crossing signals. The dispatcher may be not notified immediately or after the car mover is clear of the track. Now, there's buffer cars in between the hazardous materials and different from Class 1's hazardous mass and radioactivity, and from the units and multiplying units. The HY rails are vehicles used from both rails in roadway operations. Anything from the passenger rail, pickup truck, and large crane can be outfitted in a high rail attachment. The rail guidance and providing the small steel flange and propulsion and braking and are achieved either of their rubber tires of their steel wheels and depend on the high rail design. See for Figure 18 of the example of the wheel of the vehicle equipped with the high rail attachments. The high rail house should be placed on any track until permission is granted to dispatcher carrier and shall be taken in signalized crossing by the high rail may not be active to the crossing signal. The dispatcher shall not be notified immediately from the high rail is clear of the track. And other railway equipment, the addition of the above equipment is in there other pieces of the equipment which move in the other traffic. Example of the track maintenance of the motor maintenance manual wheel of MOW car and gang car, sport car, push car, tamper, the insert brush cutter, maintenance, speed swing, hand powered track maintenance equipment, etc. 5. The railway car. The railway car naval activist consists of several basic elements. The elements include the roadbed ballast, subballast, subgrade tie plates, royal gauge rods, point guard switches. There are the spikes and secure the rail and complete with joint bars and the nuts and bolts and secure one of the section to another final components of such frogs which in points the stock rail, switch ties and switch stands allows tracks to certify in accordance with the Navy FAC Instant 112300 or 11,230.1 series. The track's components, see figures 29 to 21, illustration various track structure components, the weight of the rail section measured by the pounds per yard, the gauge of the track measured by 5.8 of the inches allowed, or inches below the head of the rail, and standard gauge of 5 1/16 and a half inch is the rail specifications are stamped on the side of the rail and includes the manufacturer date of the manufacturer rail section designates and includes rail weight. The manufacturing process of these are basic track components. You have your stake, your anchor, your washer, your tie, double-ended tie plate, your single shoulder tie plate, your tie, and your bolt and your tie bolt. Now, this is a picture of a turnout with the switch points and 2 throw points, a switch rod heel, and 2 frog rails and guard rail and throat and heel bolt, and a switch stand and a connection rod. And this is 220 with a spindle, and a switch stand and a connecting rod and throwing lever. Now, the frog of a switch in spring face outfaced frog guardrail. Track geometry includes such items as gauge, line, and surface cross level, super rail evaluation profile of every member of the train crew who should be located out for the signals in train. Track geometry is unsafe. A simple example of the wide gauge could cause the wheel to drop, derailment. The wide gauge often exists as the condition poor and several spikes in a row of missing in curves. They can often be spotted before wear marks of the rails and only extended on the part way across the rails. Several low joints in row can also be serious track geometry defect conditions of the harmonic rail. Rock and roll continuously, a wheel derailment. Although these types of cross-level defects are often hard to spot, the train obviously close to the motion, indicating the situation that should be reported in Figure 2.2 and 2.3 shows the measurement of the gauge and cross-level gauge. The standard gauge is a 56.5-inch gauge with about in the gauge measurements. Cross grade measurement, and then they have a blue stake on the other side. I don't know. If it usually goes by 1 to 2 by 200 by 2/10 of a lift up or per stake. And Section 3 operations and procedures, and I think we're caught up. Thank you for listening.